All right. Hello, everyone, and thank you so much for joining us this afternoon. My name is Hannah Kripo. I'm the Content Marketing Manager here at Certiport. We're so happy to have everyone joining us for our Unity Certified User webinar today. Now, this presentation is being recorded, so all registrants will receive a link to the full recording after our presentation is wrapped today. If you do have any questions, that does mean that everyone, of course, is on mute, so feel free to drop into the chat or the Q&A feature, and we'll make sure to address those at the end of today's presentation. Today, we'll be talking about navigating VR, AR, and programming in education, and we're privileged to be learning from David Manning. David worked as an educator for over a decade in the classroom, and he was the Game and Simulation Academy Director for Volusia County Schools for the last 8 years. In that role, he was creating a curriculum that is used with students in grades 9 through 12 to prepare them for future careers in the game industry and related fields. And we are very lucky enough now to have David working with us as a content developer at Certiport. So David, we're so grateful to have you here. I'm going to go
Thank
ahead
you.
actually and stop sharing
Sure.
and give you a chance to share your slides and dive into the topic with us.
Thank you, Hannah. All right. Well, hello, everybody. As Hannah introduced me, my name's David Manning, and I was an academy director for Game and Sim for Volusia County Schools for 8 years. I also was the program assistant and created curriculum for the entire district as part of that role. And I also was a fellow with NASEF, the North American Scholastic Esports Federation, where I created curriculum for them as well that was spread globally. So today we're going to talk about navigating VR, AR, and programming in education. This is something where, especially if you have a program where you have the opportunity to offer um, students the opportunity to work with VR and AR and programming, it's something that can really boost your program in the eyes of both your students and the administration, parents, the community as a whole. I'll tell you, when you have, screenshot or pictures that you can put up um, showing your students working in virtual reality, using that technology to learn, it really, really boosts what you're doing and gives an air of wonder often to people. They can't believe that students in schools are learning this stuff at high schools. And it's really, really amazing, the response that you'll see. Um, so first, let's talk a little bit about Unity and what it is. So Unity is primarily a game development engine. It is designed to be a place where you can go in and create game experiences, but it is used for much more than that also. You can create architectural, demos with Unity. You can create, um, there's Unity has been used to for the create backends for robotics and for self-driving cars and things like that. So it's more than just a game development engine. It's been used in movies, but its primary role that we've seen in the market so far is as a game development engine, and it's probably the number one game development engine for independent studios that aren't these big mega studios that put out AAA games constantly. If you're a smaller studio getting into 3D and VR and 2D games, Unity is one of the more enticing picks for game development for you. So what are the careers that students could do after gaining skills in Unity? Well, in game development, there's a lot, right? Quality assurance testers probably the starting point in a lot of game development careers. Then there's junior programmer, sound designer, UI artist, developer, project manager, and then finally VR and AR developers. These are well-paying careers that it's possible to work in them all over the country. And then non-game development, there's architecture, engineering, construction, immersive simulations. I have several students who actually went into, instead of game development when they finished my program, they were working on simulations used by the US military for troops, for training troops, which is very, very cool. All right, so what are you going to need? if you want to offer Unity in your classroom, specifically you want to go in the VR and AR direction, what do you need to get started, right? Well, before we get into the technical stuff of what you're going to need for a computer, one thing I'm going to definitely point out is you're going to need space. Um, One thing is when it's not as bad with AR, obviously, because there's some pass through, right? But with VR, most of the time, the person using the VR headset is completely cut off visually from the real world. They can only see what happens in the game, and it can be somewhat difficult to manage if you have limited space. So you want to try to get as much space as you can for that. What I did in my classroom was I actually had areas of the room that I would block off using tables or other physical objects that I could use to separate everyone else from the people who were using a VR headset at the time. And part of the reason for that is that students found it endlessly hilarious to mess with someone who was wearing a VR headset because they have earbuds in or whatever, and they'd have the VR headset on. They're cut off from the world, so it was immensely funny to them to sneak up behind the person and touch them on the back or scream suddenly or something like that when they were trying to do something that was like a shark attack simulation. And so the person in the VR headset was kind of already creeped out, and now suddenly someone behind you screams, and it makes you trip and fall and potentially damage the very expensive VR headset. Um, but the other problem that you have with wanting separation is they can't see. And if you have room scale VR, which is where they can move around and they can set borders for themselves and stuff like that, but where they can move around in the real world to navigate the virtual reality environment, the real world is a hazard for them, right? If some student just happens to be walking by at the wrong moment and you haven't roped off your space, there could be a collision. The VR headset could get damaged. Both students could get hurt physically. It's definitely a concern that you have to make sure that you're addressing first and foremost. Student safety should always be your number one priority. So trying to have that space for them to do that. Now, you don't always have to do room scale VR. You can have your students working on projects where they just sit in a chair and do the VR stuff. But I'd still recommend that you section them off from the other students so that there's nobody, tempted to mess with them or anything like that. And before you have students working in VR and AR, set consequences for people who attempt to mess with someone who's cut off from the world that way. You don't want to have to sort of negotiate those consequences after the behavior has already become a problem. You want the students to know in advance that this is going to be a problem because you want the students to feel safe in your classroom working in their VR environments on their projects. So always something you want to do ahead of time. You don't want to be reactionary to the behavior. You want to be ahead of the behavior. Um, so, um, moving on into what you're going to need technology wise. Um, so unfortunately there's a lot you need to avoid if you want to work with VR and AR. Um, and I know Apple just put out their new, VR headset. It is very expensive, and it is very fragile, from what I understand. The glass on the front is getting cracked very easily by users. There's lots of reports of that right now. I always say avoid Apple computers. Most game development um, done in VR is still done primarily on PCs. And so setting up your students where they're primarily developing games in Apple would put them as kind of outliers for the rest of the industry. Um, so Windows-based PCs, you could go Linux, but again, that's not typically the norm. I've seen that, it's primarily Windows is where you're going. Um, you don't want to have all-in-one machines. And one of the major reasons you don't want all-in-one machines is because VR and AR technology requires a very hefty GPU or graphics processing unit. you can't go with these all-in-ones typically because the all-in-ones are basically a laptop that's just built into the monitor that you hook a keyboard and mouse up to, right? Um, you don't want those because they're typically non-upgradable, like a laptop. They're more like a laptop than a desktop. You can't put a better graphics card in there, and the graphics cards they come with are very, very poor typically. Well, not even cards. They're typically just they use a APU. So it's a CPU, a processor, and a graphics card kind of built into one chip. And those are much weaker than you would get from dedicated CPU and GPU. And you need that power when you're working in VR because you're rendering the scene twice instead of once so that you can get the different image to create that virtual reality effect in the glasses. So you want to avoid all-in-one machines. Mini towers can be okay, but I really, really, really recommend you avoid them because again, you can't put a full size video card. I would show you my GeForce 4080 that I have here with me right now if I could pull it out of my machine and still have my machine work. But the graphics cards are getting to the size where they're like almost the size of a PlayStation system all by themselves. And that you don't need the high end like that. You can go much lower end, and I'll there's some recommendations on here that we'll talk about. But if you get a mini tower, it's typically if it comes with a discrete graphics card at all, it's going to be a low end one, and upgrading it is going to be really hard because you have to find another discrete graphics card that'll fit in your mini tower. And those mini towers also typically have very weak power supplies that are just enough to kind of power the PC as it was originally designed. And so if you try to upgrade the graphics card, well, you're probably not going to have enough power to do that. You're going to need to upgrade the power supply. And to upgrade the power supply, well, it's a mini tower. It's not standard. You're going to have to hope the manufacturer has a power supply that fits the case. Otherwise, you're going to have to buy a new case. And now you're buying a new case. You're buying a new power supply. You're not, why did you buy that machine in the first place? Avoid mini towers. Laptops, especially Chromebooks. We don't game design on Chromebooks if we can help it. Now, that being said, Unity does have a program where you can use a Chromebook to use Unity through the cloud. There is I believe it's a monthly cost for that that you can sign up for. And if that's the scenario where you're stuck with, that's still workable. Like you can still make that work. Just understand that oh, the cloud adds latency, right? It adds lag because instead of just communicating from the tower to your VR headset, you're now communicating from the tower to some server somewhere and then back to your tower and then to your VR headset. That can make students sick really easily. Lag can create a lot of motion sickness issues with students or anyone really. I get motion sick from that type of lag. And so that wouldn't work for me because I would be tossing my cookies anytime I was trying to try out a student game through that cloud interface. But if that's all you've got the ability to do is that cloud interface, it can work for you. Just keep in mind that you could have some motion sickness issues because of that lag that you're introducing to the equation, and be prepared to have solutions for working around that. Um, but typically, you want to avoid laptops if you can in general. Desktops are the way to go. They're upgradable. You can upgrade the graphics card if you need to. You can upgrade, RAM, all that stuff easily. Laptops typically don't have dedicated chips, but they do on the higher end. But you're typically also paying twice as much for a laptop of equivalent power as you pay for a desktop. And even when you go one for, like, say, the graphics card, like a laptop GeForce 4070 is not as powerful as a desktop GeForce 4070. And that's confusing. I get it. But you're not going to get the same level of power. And so if something says in order to do this, you need a GeForce 4060, they're talking about the desktop version, not the laptop version. So if you go like, oh, I'm barely meeting the minimum system requirements, but in a laptop, you're probably actually not meeting those minimum system requirements and you're going to run into issues. Um, but recommended PC specs. So the 3060 from GeForce is a last gen card. Right now we're on the 4 series, the 40 series graphics cards from NVIDIA, but a 3060 is still powerful enough to do probably everything you needed to do right now. Now, if you want to future proof yourself a little bit, the 4060 is a much better investment. And the more graphics RAM you can get in your budget, the better, especially with VR, because again, you're rendering the scene twice instead of once. So you're using much more power than you would normally. On the Radeon side, the 7700 XT is probably the minimum I'd go. Um, the the Radeon cards typically get a bad rap with students because they are lacking in some ray tracing power, and they don't have NVIDIA's DLSS technology, which is frame AI frame generation. But for the purposes of making the games at a student level, that stuff doesn't matter as much, and you shouldn't need that stuff in order to work in Unity and get your projects done. So Radeon or GeForce, just make sure you're sticking to around these power levels, and you should be fine. Um, Processor wise, going with a last gen chip is probably fine. I wouldn't go below an i5 12600K or a Ryzen 5 5600. One thing to keep in mind with the Ryzen chip and the Intel chip is that these are our last gen chips, and they're using an old motherboard layout. So if you wanted to get these with the expectation of upgrading the processors down the road, you're not going to be able to. So go with a more current gen chip if upgrading is something you think your program may want to do in the future. Even if it's a little bit of a lower end, but it's a more modern chip, it might work out for you. Just try to make sure that the power levels are kind of equivalent to this. Um, Absolute minimum RAM is 16 gigs. Don't go for 8 gigs. 16 gigs should be your minimum. 32 is the sweet spot. Don't worry about over 32. If you go 64 gigs of RAM, you're not going to see a benefit really most of the time. Like 99.9% of the time, you're not going to see a benefit of 64 over 32. With 32 gigs of RAM, though, you will see a benefit over 16. You just have more RAM for objects in the scene and things like that. It'll run smoother for you. Um, I used to recommend about a 512 uh, gigabyte solid state drive. I kind of moved that up to a terabyte just because file sizes are getting so much larger. Um, and especially if you're going to be having some like Adobe like Creative Cloud on there for them to create assets. If you're going to have Unity on there and possibly multiple versions of Unity to work through different tutorials you're doing, your hard drive space fills up fast. And if you've got 6 or 7 periods a day of students using these computers, all those periods, their projects take up a lot of space too, and so you're gonna fill up that hard drive space fast. So I'd recommend a minimum of a terabyte. I do not recommend anymore that you go with the old style hard drives. Solid state's really the way to go. The computers boot much faster. Everything operates faster. It's the computing industry is moving on from the old style hard drives for anything more than just file storage. Um, I put Windows 11 as the recommended minimum. And the reason for that is that next year Windows 10 is being phased out, and you don't want to go for a Windows 10 machine if your district supports Windows 11 because you're going to run out of support for Windows 10 next year. So Windows 11 future-proofs you so that your program can use the computer for many years without having to worry about updates for security purposes and patches to the OS. And then you're going to need a couple of quality VR headsets. Now, unfortunately, there used to be some headsets from like HP and things like that that used Microsoft VRs. I forget the term for it now, but they had like a VR thing from Microsoft where they had some cheaper headsets. Microsoft has announced they're removing that feature from Windows going forward. So those headsets are a lot of their features are being killed off, and they're not going to work so well going forward. Support's basically being dropped for them. So be careful about that. The best headsets on the market for this type of program, in my opinion, are the Meta Quest 3s. They have video pass through so the kids can, be able to see outside the headset if they need to quickly. They're self-contained headsets. They can be plugged into a computer to work with a program that's on the system, but they don't have to be. They can also be standalone where the kids take their program and compile it and then move it onto the headset, and then they can use it wirelessly somewhere else in the room if they need to without being tethered. The other thing that's nice about the Meta Quest 3 headsets is that they don't require those light boxes. A lot of VR headsets require light boxes that need to like stand on poles or be mounted to the walls or something. that are on opposite corners of where the student's going to be while using the VR headset. And the problem with that is that those light boxes are very fragile. And if they get scratched or dinged or whatever, then they can stop working, and they're very expensive to replace, typically like $200. And they take up space, and you have to mount them sometimes, and they get knocked over, et cetera, et cetera. I just found them to be a huge pain to set up and calibrate and all that stuff. And the MetaQuest 3 headset, it's inside out tracking. So the headset does all the tracking for you with the controllers, the motion controllers. So it's all self contained. You can put those headsets in storage and then pull them out. And once they're up and running, they're up and running. There's no like, oh, let me get the light boxes out. Let me hook in these cables, extra cables and stuff. And you just need one cable to get those MetaQuest 3 headsets connected to your computer, which is USB-C. So that's the other thing, is try to make sure that the computers you get have USB-C if possible. If the USB-C is built into the graphics card, even better, but not a necessity, just a nice thing to have. And then you want to buy like the nice lengthy USB-C cables. The other thing you want to watch out for with those USB-C cables, though, if you're going to be using those a lot, is I typically would tape the USB-C cable to the headset, because you don't want the kid moving around a lot and that cable getting a lot of pressure at the connector, because you can break the connector for plugging the USB-C cable into the headset. And then you've got to basically replace the headset, because there's no way to charge the headset. There's no way to hook it up to a computer anymore. The headset's, for all intents and purposes, done unless you send it off to Meta and get them to repair it, which is going to be probably cost prohibitive. So instead, just have the cable like up at the strap level, and like tape it or something there, so that the pressure is going on the tape and not the connector piece where the cable is being plugged into the headset. All right. So what potential problems could you run into? Well, one problem my classroom ran into a lot was overcrowding. I had a very popular program. The last year that I was a teacher, the academy director for that program, we actually expanded out to have two teachers teaching the program, because there were so many students signing up, and we couldn't have them all in one class. So we had two teachers with all of the classes being full packed. And unfortunately, even with two teachers in all the classrooms, both classrooms available, we still had administration okaying more kids than we had computers for. And that's obviously a problem, because if the kid doesn't have their own computer, how can they work in Unity and do programming and things like that? Having enough headsets for everyone isn't necessary. You can create a calendar of, okay, who sign up for a spot for when you need to test out your game with the VR headset, and warn the kids, the earlier you sign up the better. You don't want to wait to the last minute and not have a spot available to test your program and turn in an untested program on the headset if you can avoid it. But there are ways for them to test locally on the machine as well that don't require the VR headset. So if for budget reasons or what have you, you don't have access to any VR headsets right now, that doesn't mean you can't get started. You can still do an emulator on the machine. Also, for kids who get sick, from the VR technology, they can use an emulator on the machine to emulate the VR headset and just use it using a regular monitor. And also, for if you're using the cloud-based Unity, that can help to prevent those motion sickness issues with your students. But overcrowding, major issue I ran into a lot, where administration is like, you're so popular, we want to put 40 kids in your room. And you're like, yeah, but I've got, 25 computers. That means I'm going to have 15 kids sitting there without a computer to work on. That's not going to work, right? So work with your administration, try to prevent that from happening. Lack of budget for needed technology, that's a popular one I hear. Now, in Florida, we have CAPE funding, where you can get funding for your program by doing industry certification. Um, Other states have different ways of doing funding. Perkins funding was a popular one. But if you do lack the budget for needed technology, one thing you can do, especially if you've got some passionate students who want to support your ability to teach what the game design or what have you with VR, then there's other types of fundraising you can do. Start a club, have a charge for that club, run events for the club where you charge. I used to do lock-ins where the kids would come in on like the weekend and spend all day coding or playing video games or whatever, and we'd have events where we do. We would do uh, membership fees for joining the club. And the other nice benefit of having a membership club, especially if you're doing a game club where they come in to play games, we saw a lot of students who'd come in and have behavior issues. Well, as soon as we started charging for membership, that stopped happening because the kids would be kicked out of the club without getting their money back. So as soon as we charged money for the club, the behavior issues kind of dried up, and we just got kids who are really passionate about being there and having fun and participating with their peers. The other thing you could do is I was in a low income district, and we had several students who really wanted to be a member of our club or what have you, but couldn't afford the membership fee. They were too low income. And we would sometimes get sponsors, teachers or members of the community, businesses even, would sponsor low income kids to be able to join the club, and they'd provide the membership fees for them. And that was really cool. And plus, we would offer other sponsorship activities and things. And we'd, have advertisements we could put in posters on the wall for different businesses, or give the kids free stuff from those businesses with the businesses, details printed on the outside of those materials and stuff like that. And in exchange for that, we would get funding for our program so we could offer what we wanted to offer. Lack from supportive administration. I occasionally would have administrators walk in with, school board members or business community members, whatever, and they'd be like, "Oh, this is Mr. Manning's room where they play video games." And meanwhile, I'm like explaining, how variables work to a group of freshmen, and not a single kid in there is playing a video game, but I'm still introduced as the guy who lets kids play video games. And you need that administrative support. So you want to explain to the administration, why the kids are going to be passionate about what you're doing. You want to show them, the rigor. My class was not an easy class. I had a lot of um, students would fail out in the first year, but second year, third year, fourth year was pretty steady because the kids would, know what was expected of them. But they would join my class hearing these things of like, this is the class to go to play video games or what have you. And they'd come in and be like, when are we going to play Call of Duty? When are we playing World of Warcraft? And you're like, never. And they'd be like, that's what I signed up for. And, then they would shut down and not want to do any work. But the kids who were passionate about it would continue on, and they would thrive, and they really loved the program. Lack of support from IT. That unfortunately is a huge one. We ran into an issue. We bought a bunch of MetaQuest headsets, and Facebook is on the same servers because Meta is the parent company of Facebook and the Quest headsets. And so our school district IT department shut down our access to the ability to run the MetaQuest headsets after we bought them and had them approved. We would have one time I had someone from IT show up in my room to unplug our computers in the middle of a lesson that where students were working on stuff because the computers were accidentally pinging Facebook servers, and they were like, we're here to shut everything down because kids are trying to get on Facebook. Not a single kid in that room was trying to get on Facebook. It just, there was something that was trying to ping Facebook servers for some MetaQuest update or something. We weren't even using the MetaQuest headsets at the time, but the software was running because of something else we were doing. And it just was a constant struggle. So if you can get IT on board, thankfully, I finally found someone in our IT department who was passionate about gaming stuff, and they became our advocate within IT, and they pushed things through for us and got us approved for things, and they helped us immensely. Like we couldn't have kept going without them. So if you can get IT on board, then you're going to be in a much smoother sailing. We already talked a little bit about stigma of the class being tied to video games, but I mean, one of my most heartbreaking moments as a teacher was there was a girl in my class who was really, really awesome at the work she did. Her art was outstanding. The games she was helping to create were the best in the class. And she came to me very upset, tears in her eyes one day because she said that her parents told her she couldn't continue to take the class the next year, despite being an A student in the class and everything, because video games are for boys. And because she was a girl, she couldn't focus on that for her career, and she had to do something else. And that broke my heart. And it's that stigma of being related to video games can be rough. Now, if you're an engineering class or architecture class or something like that, maybe it's not as big a concern. But in a game design class, it was an issue that we had to deal with a lot. Thankfully, she was able to have her parents come in on like a parent teacher night and see some of the projects she was working on and how excited and passionate she was, and she was able to stay with the program. But that was one of the things we ran into, was that stigma. And then technology issues. You've got this day planned of like, hey, we're going to be doing this thing that requires this online connection, and then the internet goes down for a week, and you're stuck, trying to find other things to do in that time, until the internet comes back. Or you've got 25 computers and 25 kids, and two of the computers decide that their video cards want to stop working suddenly, and IT tells you it's going to be about a month to replace those two video cards. So now you're struggling to get those two kids the ability to work, um, for that time period while the video card's getting replaced. One thing I do suggest, if you can manage it in your budget, get an extra computer or two that you can keep in storage that are just ready to go in case you run into tech issues or a computer has to be down. Or have your administration give you more computers than what you're using in the classroom, and that way you can just shift where someone's seated if something happens. I know it's a tall order. Most principals and stuff want to fill a room. If there's 25 computers, you're getting 25 kids. But if you can get somehow the budget for it to get extra machines put aside for those technology issues, you're going to be in a better spot. All right, so promoting your program. Um, you definitely are going to want to create social media accounts for your academy or program. Be very careful about what you post. I once posted a screenshot of a game students were doing, and um, the word kills was in the bottom right corner of the screenshot. And um, someone who was very upset with us in IT screenshotted that tweet and blew it up poster size and took it to the school board to complain about us. And the school board told them to immediately shut us down. So we were in the middle of projects, and suddenly our internet got shut off mid-project. It killed a bunch of student progress. Um, it blew up basically. And we even had our principal going to the school board members and saying, "Hey, the word kills is used in volleyball. This isn't as big an issue as it's being made out to be." But it turned into a multi-month issue that we had to deal with, and we had students talking to the school board. I was so proud of them. Without any of my prompting, they went with their parents and they spoke to the school board and let them know that what they were working on was important to them and for their futures, and that they wanted the school board's support, and they didn't want to be you know held back because of any sort of stigma about verbiage that was being used in the projects they were working on. I also created um, uniforms and shirts uh, for my academy students. So I had an academy. It's a little different than a program here in Florida. So a program, is like it's just an elective, right? An academy, you actually can apply to be into it, and you'd be in it for the 4 years that you're in high school. And so for my academy students who had applied and got into my academy, I had a uniform that they were required to wear once a week, which was just a shirt with our logo and stuff on it. But it really created a sense of connection with the students, and it was free advertisement for us, right? Well, not free, we had to pay for the shirts, but it created that advertisement for us as the students would walk around and wearing our academy uniform throughout the school day. And we could go to events, and those events, I and the students would all be wearing our uniform, and so we'd look much more professional. Speaking of those events, take a couple of your best students and make them into ambassadors for your program, if you can. If that's something your school is up for, bring them to these events. We had like a high school showcase where academies and programs would go and show off what they would work on. I would bring my ambassadors. The ambassadors would be wearing their uniforms, and they would talk to people with me about what is being done in the program, what they're excited about the program. They would go to middle schools in the area to promote to middle school students, hey, this is what you could be doing in high school if you apply and you keep your grades up and things like that. Um, they would be trained in what to do as an ambassador. We'd have booths we'd set up at community events like in Orlando we have Otronicon, and we'd set up a booth at Otronicon, and the ambassadors would talk to the public about the programs that they were creating and the work they were doing. And often those ambassadors would also go to other booths where there were game designers and stuff, and they would get contact information from them to work for them as beta testers or things like that on their programs. It was great networking for the students. And we ended up having internships and things like that that we grew through those ambassador programs. Um, and like I just talked about, attending community events to show off academy work. I mean, you blow people's minds. They're like, "What? We didn't have this when I was in high school." As you know, you've got you know, your student ambassadors showing off some application they created in VR, and people are blown away that high school students created this program and are showing off what they've done. And it's just it's amazing the feedback that those kids will get and bring back to your program and tell everyone like, hey, everyone was so impressed by this program we made, and I got these business cards from people who want to work with me when I graduate, and et cetera, et cetera, et cetera. And this one college recruiter said that they want to work with me getting a scholarship. It's so great for the students to go to these events, and it's so good for your program. I've had parents who moved housing to have their students be able to apply our program because their our program was so sought after by their kids after seeing it in these community events. And that really is something special when a kid can convince their parents that we need to move so that we can attend this one high school that's got this one program that I absolutely need to do because I'm so passionate about this being my career when I finish high school. Okay, let's keep going. So some free resources. So Unity does have some built-in tutorials to get you started. There's also learn.unity, which is directly through Unity. It's on their website. And learn.unity tutorials are pretty good. They're a really good starting off point. You can really like the only issue I have at all with learn.unity is that often tutorials are not for the same version of Unity. And so you're going to be installing multiple versions of Unity so that kids can jump from one version of Unity to another while, oh, I think I skipped ahead by accident. While while they're going through the tutorials, and that takes up a lot of hard drive space, and kids will run into issues where they're using the wrong version but accidentally, and then go, "Why isn't this working?" And you're like, "Well, you're on this version; it should be this." Um, but that's also kind of standard of most Unity tutorial stuff that it can sometimes jump from version to version. Khan Academy, Code.org, Hour of Code, Free Code Camp, Code Monkey, Udacity, these are all good sources of um, stuff that you can use in your classroom for instruction in Unity and C Sharp. C Sharp is the programming language primarily used in Unity. Um, all great resources. All of these are free options. Some of them have paid options as well, but you can at least get started for free. Of all of these, the ones I used the most were the built-in Unity tutorials and Learn.Unity. But I have used all of these in my classroom in some capacity, just not quite as much as Learn.Unity and built-in tutorials. Paid resources. So full disclosure, I work for Certiport now, and some of these are Pearson products. But there's LearnT, there's Geometrics. On Humble Bundle, you can go on and purchase book bundles. Udemy has courses, Coursera, LinkedIn Learning, Skillshare. So um, the Humble Bundle is great for buying a bunch of digital copies of books for a really inexpensive price. I would recommend that you maybe use those for yourself as the instructor to bring up your game a little bit for helping students out. But I try to avoid telling people, well, we'll get into resources to avoid in a moment, but you can run into trouble if you're planning on using a book, like a static book for your curriculum. Um, LearnKey is, a full experience for getting the kids prepped for Unity certification. Geometrics I see so many teachers have a misunderstanding of how geometrics works. A lot of I've seen there's teachers out there that will take kids, put them in the geometrics practice tests, and that's the only instruction the kids got on the exam, and then throw kids at the exam and hope they pass. The geometrics is not just a version of the exam that you take to learn the answers and then you sit for the exam. The geometrics practice tests are completely different content. It's in the same skill groups, it's in the same objective domains, but the questions are different. And so kids just going through and memorizing geometrics, items, if they have no other knowledge about the material, they're going to fail. It's just a, almost a 100% guarantee that unless they have really, studied on their own in some capacity, the geometrics is not enough to prep them. The way you should be using the geometrics, in my mind, is it's there to teach them what the test will be like, so they don't panic when they're actually sitting for the real exam for the first time. It shows them the different question types, and gives them an idea of what they need to work on, right? Don't have them just go through. And I know some school districts are bad at this because they say like the kids need to pass, their practice exams so many times before they sit for the real exam. So teachers are like, oh, well, if they pass 3 times, after I gave it to them 3 times in a row, then I guess they're ready. Doesn't mean they're ready if you do it that way. Have them take the geometrics exam, find out where they need help, and then offer more instruction in that, and then retest them and see how much they improve. That's what you want to use geometrics for. Um, and then the other stuff, Udemy, Coursera, LinkedIn Learning, Skillshare, those are all, good resources. They are paid resources, but definitely be careful about when you're signing up for this stuff. Make sure whichever one you're looking into that it's been updated fairly recently. You don't want to buy into something and then find out that they haven't updated it, in 6 years or something like that. And the test has been updated since, and now it's not even the skill groups don't align anymore or something like that. So just do a little bit of your homework before you put some of your program's money into one of these programs. All right, resources to avoid resources that require a big financial investment for a static curriculum. Our school district got burned once because we paid a ton of money to have access for multiple years to a curriculum that we found was really good at the time of purchase. What we didn't know is they were never planning on updating that curriculum ever. So we paid for multiple years access, and then they, like a month or two later, announced that they were never updating that curriculum. And that curriculum was set in stone, even though the actual exam was going to be updated the following year. It was going to leave us behind. Like we were going to be still paying for this curriculum that wasn't going to actually teach our students what we needed them to know about the new version of the exam. So be careful about that. Big multi-year investments, I usually say avoid them, even if it's going to save you 5% or something like that, 10%, unless it's a huge percent where you're like, well, we'd be stupid not to get the multi-year because it's like almost the same price as 1 year. Avoid those big curriculum investments unless it's with a company that is telling you that, yes, we are, as part of this agreement of you paying for multiple years, we are saying we're going to keep the curriculum updated with the exam and you're not going to be left behind. Ask around other instructors at the high school and college level for what resources they have found useful, right? If there's a superstar teacher in your district whose students are passing the exam and they have curriculum they're using, don't reinvent the wheel. Go ask them, what are you using? Oh, we're using LinkedIn, or we're using LearnKey. Awesome, I guess I'll go buy the LearnKey and bring my numbers up, right? So use your fellow teachers, they're a great resource. And avoid most physical books. I know I talked about that a little bit with the last slide. They don't age well with the speed Unity updates. It's definitely true. And I know, like, I've had the school librarian come in a couple of times. They're like, hey, I got this Unity book for you. I'm so excited to help you out. And I'm looking through the book and I'm like, oh, this is like a couple of versions of Unity old. We don't even have any tutorials that use a Unity version this old anymore, but I appreciate the effort. What, really? But this book was high rated. I'm like, yeah, it was high rated 5 years ago. So just be careful about physical books. They don't age well. With the speed that Unity is developing and changing over time, you kind of need to go for an online curriculum if you can. Um, So best way to prepare your students for the exams, provide real world scenarios, right? Give them projects that are real world scenarios that they can work through to learn how to use Unity and how to, either code in C# or create the art or whatever it is that you're working on with them. Um, Create project templates where the students are allowed to flex their creativity with the project. Student creativity really, really boosts how much they care about what they're working on. When I first started teaching Adobe stuff, I was using some pretty bland tutorials to teach it, and student buy-in was low, and performance on the exams was kind of low. I then went and redid a lot of the stuff that I had. So instead of like, hey, take this guy off the park bench and replace him with this puppy, which the kids could care less about, I was like, all right, take this destroyed city and replace Godzilla with whatever you want. So, you'd have a destroyed city with like Honey Boo Boo standing over it, breathing fire breath over the city and stuff. And kids would be laughing and carrying on. And they would learn that material so much better than when it was replace the man with a puppy and it became like replace Godzilla with a different monster of your choice, right? It just it lit their imaginations on fire and it got them more invested in the what they were learning, and they learned much faster and much better. Drill the basics and keep including the basics in grades for projects. I kept it as 20% of your grade when I was teaching the coding stuff. 20% of your grade was following our guidelines for how to um, for naming conventions. If you didn't follow my naming conventions, you lost 20% of your grade. Because I wanted to drill in them to them the need to keep those naming conventions. And so we'd go over them every so often, and we'd re-go over them and re-go over them. And it was always part of their grade on every rubric they had. And that can get those good habits ingrained into them quickly. Practice tests, if you're going to do, whether it's a regular summative that you're working on for the kids, for your class, or it's an industry exam, you got to have practice exams to get the kids over that test anxiety and get them prepared for what's going to be expected of them. They're going to perform much better than if you just, throw an entirely different type of prep for them and then have them sit for say, a multiple choice exam or something like that. One of the exam types I used to love for programmers would be I would write some code and I would break it in multiple places, and they were graded on being able to fix the spots that I broke in the code. And the way we'd practice for that is I'd break other code and give them that to fix. And so it wasn't the first time they were seeing that problem when they sat for my summative. Um, and try to arrange, if you're for industry certification, I was a big advocate for having an in-school prep day, the day of the exam. Basically, we'd have an in-school field trip where the kids would all, come into like the auditorium, and we'd go over things that they should have memorized in their heads before going into the exam. Different C# coding things, or for the artist exam, we'd go over different things that how to do certain things in Unity, stuff like that. For VR, we'd go over different things about motion sickness and things like that. So we would have a prep day where we'd have them just sort of immersed in the curriculum for about half a day and then sit for the exam. And the scores were much better than just having kids come in for your class period, like it was a normal day, just do the exam that period and then move on. Where, maybe they had a bad period the day before, the period before yours, maybe they just got a bad grade on something or something. There's a million things that could have distracted them from keeping their head in the game for the exam. So anytime your administration is willing to work with you to give you more time with the kids before they sit for the exam, the better. Um, and then motivating your students. We would do so much. These are some of the students that I had in my program, doing some VR stuff at a local business that was offering them internships. And field trips are awesome. We, again, in Florida, have Cape List. And one of the things we would do is we would do a behind the scenes tour of Universal Studios, that students who pass the 3 Unity certifications, so programmer, artist, and VR, We get to go to Universal Studios, meet with the Dave School who has set up there at Universal Studios, and do a behind the scenes tour to see how the simulations for the rides are done. Students were super excited for it. Gave a lot of motivation to them. There's so much bragging that they would do afterwards of like what they got to do, and it would really light a fire under the other students to make sure that they were doing that as well. We would do competitions. I helped start an event called Game Fest in Volusia County, where students would show off their projects they were working on and compete against each other with projects. They would do esports. It was a whole day event that schools from all over the county would participate in, and it was awesome. The students would have such a great time, and did so much good promotion for our program. I also gave them game days, sometimes as rewards, where we would take a day and basically look at the games that were game mechanics in actual games that are on the market to see how it was done or why it was done or why do you guys think this is successful or why do you think this is not successful. And those game days were viewed as a reward by them because they're getting to play a video game. Game jams, participating in local game jams is always awesome. Run them yourself or find ones that are already happening and have your students participate. And that gets their name out there in the community, gets the community to understand like, oh, wow, the kids coming out of this program are actually pretty skilled. And it's just awesome. Certification recognition. Again, I talked about offering that universal trip as recognition for certification, but also, print out those certificates, put them up on your wall, have an award ceremony at the end of the year where you congratulate all the kids who passed industry certification that year. Make it a big deal because then it will be a big deal for your kids. Start a club. I ran multiple clubs. I did a gaming club. I did a Dungeons and Dragons club. I did a couple other clubs I would participate in, and those clubs would work as advertisements for my program. Kids would join the game club and go, oh my gosh, there's a class here where I can learn how to make the video games. And then, they would all come into my class the next year. So start a club if you can. I know teachers, we have very limited time, but if you can do it and you can get those kids in there for something fun, then the chances are that you'll get them in there for the educational part too. And you need to play games yourself, right? I can't underscore how important it was that kids would be talking about some game and they'd be like, Mr. Manning, have you ever heard of, Persona 3 Reload? And I would be like, Persona 3 Reload? Oh yeah. I pre-ordered that actually. I'm like maybe 50% through. How are you liking it so far? And you'd have a discussion with them on their level about the games that they were excited in. The amount of times I played a game that I had zero interest in, but my students were super hyped about, and so I could talk to them about it. Oh, and some of those games were not my cup of tea at all, but it helps you form that bond, that connection with the kids, and that's important. All right, so industry certification wise, there's the 3 user exams we offer right now: VR developer, programmer, and artist. Oh, yeah. And what I would recommend if you're thinking of entering this into your program, you should really start with VR developer. It is designed for that 9th, 10th grade level. It's more of a basics exam than the others. Artist is probably the next step up if you're going to do all 3 for one group of students. But otherwise, separate the kids out and have your programmers take the programmer and the artist kids take the artist exam. VR developer is basic Unity concepts for VR development, determine user interactions, building a scene for VR, UX implementation for VR, scripting with Unity, troubleshooting and playtesting, 40 to 50 questions, 50 minutes. I will tell you the scripting is low level scripting. You don't need the kids to be perfectly fluent in C# in order for them to pass this exam. The programming exam, they should be fluent in C# in order for them to pass this exam. This is a much harder exam. This is more for the kids who've had some time with C# code. And then the artist is for your artists, right? 2D, 3D are both covered in this exam. Asset management, lighting, excellent exam. My students really liked that one. All right, that's everything I have for today. Unless there's any questions, I'll turn it back over to Hannah.
We do have a few questions actually,
Okay.
and you've answered, I think, quite a few of them that have been popping up in the chat.
Okay.
But we'll
I'll
go
stop
through a
sharing.
couple of these
Sure.
that we have left. Do you have documentation showing that Unity is good for students under the age of 16 if being utilized in a supervised classroom environment? It says on the website that you have to be 16, but it sounds like you
Okay.
worked with the younger demographic of students as well.
Yeah, I would go from ninth grade to senior. So I think I'm aware of the stuff you're talking about saying students should be at least 16 on the website.
Hmm.
That is as far as I remember, that is purely a recommendation on Unity's part. We have no such requirement on our exams. A student in ninth grade can sit for our exam just fine. And I had no issues uh, teaching students this stuff. And really, if you have a 4-year program, you want to start them in Unity as quickly as you can,
Hmm.
because in order for them to get proficient enough to pass that programmer exam with C sharp, they have to have a couple years probably under their belt. It's not the type of thing where you can have a fresh group of students who've never used it before come in a year easily prepare them for that C sharp programming exam.
Hmm.
It's not that type of exam. You need more time with them than that. But as far as documentation that it's okay to teach Unity to kids under 16, I don't have any documentation per se, other than if you want, I can share success numbers with students who were under 16 who passed exams for me. But I don't think we have any documentation of that.
Love it. So speaking of success rates, one of the next questions was, what percentage of your students would pass the programmer certification?
So programmer is definitely one of the harder exams of
Hmm.
the three. Well, it is the hardest exam of the three. Now we are actually right now updating that exam. We are going through and we're changing a bunch of the content in the exam. The pass rate I saw as an educator was roughly, I'd say maybe like 30 or 40% pass rate on it.
Hmm.
But the exam is being updated, and one of the things that I saw with the exam when we were re-looking at it was some of the content, it's not as aligned to the objectives as it maybe should be in order for the students to really have studied the right thing in order to pass.
Hmm.
So we're aligning things a little bit better now. It should be a little more straightforward. I'm not saying it's going to be a walk in the park, but it should go from maybe like a 10 difficulty that it is now to maybe like a 7,
Okay,
which I think is more in line with what high school teachers, the feedback we've been getting from you guys, what you're looking for.
awesome.
Mm.
We'll do one more question before we close things out. Can art be created using Unity? If not, what program are you using with your students?
So there's pre-built assets in Unity that you can use,
Mm,
but I would use Adobe stuff to create assets. For skins and things like that, we'd use Photoshop. And then for some like vector art, we'd use Illustrator. But for 3D models and stuff, we would use typically in my classroom, we'd use Blender because it's free.
hmm.
But I know some of the other classes in my district were using like 3ds Max and Maya for
Hmm.
their 3D models. And what's awesome is that they were able to do industry certifications for that with Autodesk.
Right.
And I was able to do industry certifications with Adobe. So there were other certifications we could tie into with our programs because of that connection. We were making the art assets
Hmm.
in other companies' products that
Right.
also had certifications.
Right.
Mhm.
So building into that, I will just
Mhm.
give one quick plug really quickly before we get into our announcements, is that we will have training coming up this next quarter, so starting in April and May, related to design. So if you're a design teacher or leveraging, like David, multiple products in your classroom, whether that's Adobe or Autodesk or Unity, we would encourage you to attend some additional webinar sessions. We'll have the registration link live here in the next couple of weeks for that. So that's going to be at www.certiport.com/blog. And you can find all of the information about those sessions there. But thank you so much, David, for everything that you've shared with us today. I did want to give another quick plug. If you really enjoyed David's session like I did, he's going to be presenting for us at our annual Certified Educators Conference happening in Orlando this June, so June 17th through the 19th. At this conference, David will be discussing VR in the CTE classroom, so similar topic, but there's a lot of questions I can tell in the chat that we unfortunately don't have time to answer today. So we would encourage you to register for that conference and join us, hopefully learn a little bit more. You can do that at Certified, so certified.certiport.com to get some additional information about that session, as well as the registration pages there too. Second, as we mentioned at the beginning of the session, we'll be sending out a link to the recording. I saw, unfortunately, a couple of people had to drop a little bit early, so keep an eye on your inbox for that link, and then additional information about the Unity Certified User Certification Programs. If you have questions about the practice test or any of the resources that David has mentioned, we'll be able to follow up with you there. And again, thank you so much for learning with us this afternoon. David, as always, what an amazing and very rich presentation you've shared with us
Thank you.
today, so we really appreciate you taking the time to be here with us. Thanks, everyone.
Yep, no problem. Thank you, guys. Have a good day.